Alright, so this is for Math 1203, Linear Algebra, Section 1.1 for your university. Yeah, relatively easy section for most people. So I imagine many of them have tried a few questions and then they skipped or don't even bother altogether. But for people who are not totally familiar with the basic concepts of algebra or not sure exactly what matrices is. Granted, I also ran into the same situation. I thought it would be much more cooler after watching the movie Matrix, but big disappointment there. Nonetheless, so if you're one of those people who just need some brush up with math concepts, then definitely try a few questions just to make sure that as you go to other sections, you don't get confused and so on. So, anyways, we are going to try number 1. Oh no, not number 1, number 2, because you already have solutions for all numbers. Number 2, let's try the hardest looking one. Cos pi over 7 x minus 4y equals log 3, right? So, really the only thing you have to know about linear equations, we could get more in details as to what it is from calculus courses, but for most part, just for solving the question, you just have to know the x and the y have to have a power of 1, right? So not x to the power of 2 or square root of x or x to the power of x to the power of square, whatever it may be, right? So all I really care about all the variables, unknown variables, so x, y, z, whatever they use, right? All these unknown variables, they must have a power of 1, right? And for people who are not used to math just yet, whenever you have a power of 1, you just don't write anything at all. So that implies that it's 1. Just like for some of you, maybe you have taken a chemical equation. When you have a coefficient imbalanced equation, you don't write 1, right? You could. It's not wrong, but it's implied. So that's the idea. But anywho, so let's go back to the question. So I want to know if this equation is linear. So I don't really care about these coefficients. They could come up with the most complex and most convoluted numbers or irrational numbers or whatever. It's fine. All I care about is the unknown variables. So this x here has a power of 1. This y has a power of 1. This looks a little intimidating. It's called log 3. Log just simply is a different mathematical operation where it's kind of like squared or square root. It's one of those mathematical functions. For this course, I don't think it's going to be that important. Calculus, perhaps, right? But all you have to know is this will equal to some constant number. It could be 2.5, it could be 3, it could be, well, it can't be 3, but 1.5, some number, right? So every time you have log and some kind of number, it just is some number, right? You can use calculator to figure out what it is. It's going to be some number with lots of decimals. So nonetheless, we don't really care because our question isn't to figure out what x and y is. Our question is to, whether this is a linear equation or not. So nonetheless, because of these two factors, right? X has power of 1, y has power of 1, therefore it is linear algebra, right? So that's all there is. If we were to look at other questions, perhaps 2a, so 2 to the power of 1/3 x plus square root of 3x equals to 1. Yeah, that sounds, do not write like this because this implies 2 to the power of everything, right? So that's definitely not what you want to do, right? So make sure exponents stay on top and the rest of the equation goes back to its natural position. So plus y equals 1. So again, a fairly simple idea, just making sure that the x is not an exponent. Oh, actually, that's a good question. So this is A. This is I didn't copy this question correctly, but let's just assume it is, right? So if this was a case, y, which is unknown variable, has a power of 1. Good. Let's look at x though. Yes, it has a power of 1, but where's the x? It's in the exponent section, right? It's not in a normal place. Remember, whenever we have unknown variable, we want to have a power of 1, and also it has to be linear. So visually see it this way. It's going to be written the normal way instead of going to the power or stuck in the square root or stuff like that. So because the x is on the exponent space, this is no longer considered as a normal x. That's why if this was a question, your answer should be no, it's not a linear equation. However, on the textbook, it says x on a normal place. And the x is just to the power of 1, no other crazy numbers on its exponent. So this 2 will be linear. This 2 will be a linear equation. That's that. Now there's another question that looks similar. B 2x, so like that, plus 3 square root of y equals 1. Problem with this, actually there's a number of problems. X to the power of 1, 3, so it's not power of 1, so that automatically disqualifies this equation as a linear equation. But there's another thing I'd like to point out, square root of y, right? Square root of y is same thing as y to the power of 1, 2, right? So, now, there's nothing written here because that implies it's 2. But you would see something like this as well, 3 or 4 or 5 or whatever, right? So it's the same idea, y to the power of 1/3. Essentially, it's like exponent, but you have inversed it. Inverse means you flip the top and the bottom of the fraction, right? So because of that, it's not to the power of 1, therefore this one fails. It's not a linear equation, it's going to be some other equation. For our purposes in linear algebra, this is a no-no. So so that's the question 2 and 1. That pretty much brings all the point there. If you look at number 3, using the notation of formula, write down a general linear system. So I'll just do 1 so that it makes sense to you. Let's not do A. Let's do C. 2 equation and 4 unknowns. So yeah, really it's pretty simple. So you have 2 equations and you're gonna have 4 unknowns, right? So I'm gonna put it in a matrix. Oh no, actually no, can't say that because they haven't said put it in a matrix form. So I'm just gonna write down the equations like they asked, right? So I'm gonna just any equation that has a unknown variable, right? So I'm just gonna use x and y, z, and w, for example, right? Now, where did all this come from? The question did specify that there's 4 unknowns, right? So literally that's all it is. 1 unknown variable, 2 unknown variable, 3rd unknown variable, 4th unknown variable, right? So x could be any number that you can just insert it, so to speak. That's why it's unknown. It could be anything. Sometimes it is already defined, which we'll get to that, but that's all there, right? And so, but these has to be equation. This is not equation format, right? Like what we saw over here. So honestly, this is I could just do this, right? So they're all glued together, right? So that's all I care. I could put a multiplication here, division there. Really doesn't matter all that much, right? For the linear algebra purposes though, let's try to keep the equation plus or minus. No multiplication and stuff like that. That would make it complicated for the matrices purposes. So for linear algebra, whenever you said give me 2 equations or whatever, stick with pluses and minus only, right? Doesn't matter where the plus goes or minus goes. Don't really matter, right? Another thing you need to know, you should mention, is that this equals to some number. 0 is usually the best way to go about with this, because if it equals 0, it will make our math operation simple. But again, you could put 5, 6, 9, 100, a billion. Don't write billion though, you're gonna make a lot of professors angry. So make the number simple, but it just means this equation has to equal to something, right? Now, if you make it as equal to 0, you don't even really need to write it. For linear algebra, let's put it down there when we just so that when we deal with the matrices, it would just make our job a lot easier, right? So that's all there is. The rest of them, oh, yeah, and remember, they didn't say linear equation, but it's implied that we should stick with a linear equation. So yes, we can put any unknown variables, but just make sure the exponent's nothing crazy, right? They all should be 1, or not right at all, right? Like I said, if you don't write it, then it's implied is 1, right? So that's all there is. Now that's one though. Two equations, right? Theoretically, you could just write the same thing, and you have two equations. It didn't say two equations have to be unique, but just because it's sort of implied that it should be different equation. So 5x plus 7y plus 9z minus 7w equals to 7, for example. I don't know. But yeah. Oh, also note that just as a reminder, coefficient, you can put anything you want. Doesn't really matter. As long as a variable has a power of 1, coefficient doesn't really determine whether it's going to be linear or non-linear or whatever. So that's all there is. And there's no reason why I put minus here specifically. I could have just made plus here and minus here. All you have to worry about is make sure you put pluses and minuses to glue all the unknown variables together. That's all there is to it. For the number 3, let's see, number 5. Okay, so for number 5, basically they give you what is called matrices. Yeah, so basically, yeah, this matrices is essentially just x. Like, let's say you have some kind of a linear equation, right? So if you had that, right? All it's doing is, because we're just gonna put it into this box, right? So if you guys watch The Matrix the movie, this might make more amusing. This might be more amusing to you, but nonetheless, x. So we just look at the coefficient. If it's nothing there, we assume it's 1, right? So it's 1 plus, again, we are looking for coefficient only, right? 1, 0. And stuff like that, right? Now the only thing is, with matrices, we do not put any addition, plus or minus or whatever, right? If it's plus, it's nothing. If it's minus, put minus. So for instance, if there was x minus y, right? So that's not 0, by the way. That's just to show the point that there's nothing there. If it's minus, then it's gonna look like, yeah, like that, right? So we don't even put the equal sign either, right? So this is just to make it very simple. This is just to make the equation very simple, right? So that's what we. So that's the example of matrices, right? This way, row, and this way, column. That's all there is, right? So now usually this matrices of this size. So size is how many rows and how many rows and how many columns you have, right? So row, we start with the row first. Always, always, always. So we put 1 because there's 1 row, right? And how many columns do we have? 1, 2, 3. So that is its size. That's the technical term for it, right? So this becomes fairly important, especially starting in section 1.3. That's when we get to multiply and do all sorts of things to the matrices. But we will get there. To be continued. So back to 5, right? So if you have 5, you have, I'm gonna start with b, right? 6b. So that is 3, 0, negative 2, 5, 7, 1, 4, negative 3, 0, negative 2, 1, and 7. Okay, so yeah, so all the question is asking is convert this into equation format rather than matrices, rather than in augmented matrices, right? So again, so these 3 unknown variables have to be the same, right? And then these unknown variables have to be the same. This unknown variables has to be the same. This technically could be an unknown variable. For most part though, we just assume it equals 2, right? So for example, remember 5 y plus 5x equals 7, for example, right? So usually the last one implies that it's going to be this guy. Technically though, I mean, it could have been this. Oh my god. Could be this too. I mean, there's nothing that says otherwise, right? So sometimes you see professors doing this, right? Drawing a line there, right? So if you draw the line, it further implies that it's gonna be a constant number rather than another unknown, right? But you know, just as you do more questions, this will become second nature to you. So don't freak out if you're not sure what that means. But nonetheless, so let's go back. So I'm gonna start writing the equation. Now you could use x. That's quite common thing you could use, right? But again, you know, it could be y, it could be z, it could be p, whatever you want to use, right? Usually x, y, z is the most common thing to say, but you know, it doesn't matter. The only thing that matters is whatever unknown variable you choose, x, y, z, b, whatever, right? That unknown that you chose must be the same for this guy and this guy. All these columns, each column should have its own unique matrices. So the answer for this will be 3x plus, now it's a 0, right? So technically 0, 0y, but 0 times anything is 0, right? So that's why if you look at some of the solutions, they just leave it as blank, because you know it's the same thing, right? Nothing's there. -2, so -2. For this one, I'm just gonna use the unknown variable z equals to 5. Plus, I mean, it's not wrong, it's just plus, minus, you know, why bother, right? So on your solution, it was look something like this, right? Now, you can leave the gap. I think they just left the gap just to make the point that there's something missing in between. But, you know, if you don't like this aesthetically, you could technically write like this. No problem, right? The only reason why this is good when you're actually trying to figure out the unknown variables later on. Sometimes though, you want to keep the space there just so that when you compare this and this, it's like, oh, I can follow visually, right? So that's why. But anyways, so same column, right? So it's gotta be same unknown, right? This one, now 0 this time, right? It's 1, so that's gonna be plus y, right? Or 1y, but again, like I've said countless times, 1, if you don't write anything, 1 is implied. Plus 4z equals -3. 0, so we don't write anything. -2y plus 1 equals to 7. This is all they want, right? When you put in the equation format, do not write this. This will make some professors very disturbed. Yeah, it will disturb a lot of professors out there. So yeah, you only put this when you convert equation into augmented matrix format. So that's all there is. Is there anything more I'd like to say about that? No, not really. Yeah. Alright. So that's the idea. Number 6 is the same thing. Like this, just because the equation seems longer or it looks visually bigger doesn't mean it's necessarily harder, right? So don't be intimidated, and when in doubt, do those questions. Okay, so I'm doing 6b now, just in case if I didn't say anything. Sometimes I lose in my train of thought, so I have to talk to myself to sort of reboot my brain, so to speak. It's a very disturbing trend of mine. But anyways, so that's 6b. So again, same idea as before. Numbers are bigger, but whatever. So you're not going to see a line here, right? That's not what it says on the question, but it's implied that it's there, right? So, but if you choose to put another unknown rather than making the very last column as a constant, who cares? Whatever, right? you're not gonna lose marks out of this. So let's try this one. I don't know. Oh yeah, another thing. So usually we start with X, Y, Z, W, or you could mix the orders, whatever, right? As long as the columns have their own, each column has their own unique unknown variable, right? Sometimes when it gets really long, we really don't want to fumble with the unknowns. So sometimes when it gets really long, you probably notice in the solution book too, but we don't even bother putting different unknowns. We just say x1, x2, x3, x4, and x5. Or, if you don't, or just leave it as a constant, so whatever, right? Some number. So you would see that it really doesn't matter what you choose, whatever works simpler for you, right? I mean, even if it's just x, y, and z, if you prefer x1, x2, x3 just because it's just because you want to keep it consistent, doesn't really matter, right? So for this one though, I'm just gonna do what the solution book often does when the matrices get really big in size. Oh, speaking of size, what would be this size? So if you forgot how we write down the size or dimensions, I guess that's another way of looking at it for people who are in constructions. So we look at the rows, 1, 2, 3, 4. 4 rows. How many columns do we have? 1, 2, 3, 4, 5. So that's all there is. So that will be the size of the matrix, of the augmented matrix, right? So, should I erase this? Yeah, let's do that. This looks like a long equation. So, alright, so let's get into it right away. 3x, 0. No what? Oh, no, what? Yeah, 1. X. We said we're going to use x1, x2, x3, and so on, right? So 3x, 0, nothing, so I'm just going to skip it. X, so that's 1. What column is it? 1, 2, 3. That's going to be 3. Minus 4x4 equals 3. Right? So that's all there is. Let's go next one. 0 again. Skip that one. X3, but there's a coefficient 4, so 4 plus 1x4 equals negative 3. And you just repeat. This one is not 0, right? So we do have x2 this time. So plus 3x2, but the third x3 is not there. So that we skip that part. Negative 2x4 equals negative 9. Okay, and the last one, 0, 0, 0, yeah, we can skip all of these things, right? So all we care about is x4 here. So x4, and it's negative, right? So negative equals 2, negative 2. That's and that's all we really care about. Later on, when we try to figure out what the unknowns actually are, especially the last one, are beautiful because it tells you x4 equals something. When you have 4 unknown variables, you want to know all the unknown variable as much as possible. So this is already defined, right? You can't just say x4 could be anything. No, negative x4 will equal to negative 2. So if you cancel out the negatives, then it's going to be x4 equals to 2, right? So that's 2. Then maybe we can find the other ones and work our way backwards. We will talk about that in section 1.2. So just wanted to give you a little bit of a foreshadow. 6 is done, and 7, is it any different? And this number 7, again, it's exactly same as number 6, but we're just going the other way around. So instead of starting with the augmented matrices, all we're doing is we're starting with the linear equations, and then we're putting it into matrices format. That's all there is. I'll just do one, just to make sure that, we're on speed as to what it is. So let's do B. So it's going to be... Where you go, 6x1 minus x2 plus 3x3 equals 4. Where'd you go, 5x squared minus x3 equals 1. Right? So, yeah, okay, there we go. Okay, so yeah, so that's that. So again, now we're putting in matrices format, right? So now we want boxes. Okay? You are in, yeah, so that's all there is. So let's look at the columns here. So I have column 1, column 2, and column 3, and technically column 4, right? So remember as I was mentioning why we would put empty space. One, we just condense it so that it just looks more neater. This might be why, because visually we can see, oh, like once we start copying down the coefficients, I don't really even have to think, right? Because let's say this wasn't condensed. Oh, this is a bad example because this is already. But let's say I move this up here, right? Then I have the 6, 5. Oh no, wait. This is x2, so I'm gonna have to put 5 here. We don't have to go through that word. So because it's aesthetically already organized, then all we have to do is just visually copy and paste, so to speak, right? So so it's gonna be 6. There's a negative sign here, right? So that's gonna be negative 1, 3, 4. And there's nothing here, so put 0. Don't leave it as empty. That's gonna cause a lot of headache, right? So on equations, if it's 0, don't write anything. On the matrices, if it's 0, please write 0. Okay? So have that in mind. 5x2, so that's gonna be coefficient of 5, and coefficient of negative, so negative 1, and that's gonna be 1. That's all there is. I would actually say going from linear equation to matrix is easier than vice versa, but both are pretty easy. It's just a matter of technicality. Let's see if there's something. No, yeah, everything is fairly straightforward. What happened? Oh yeah, there's an interesting looking one. Let's jump into 8C. Nothing difficult. It just looks different from all other questions. So, holy crap! There's a space here. I will talk about. Well, actually, I don't think I have to talk about it. I made the point abundantly clear, but I'm just gonna write it down in the same format so that there's no room for confusion. So yeah, we have this, right? So technically, this just like I said. I know I'm being redundant, but whatever, right? Oh yeah, I can't. Oh yeah, here. I almost wrote y, right? Can't be because these are in the same column, and this is x2. So this should be same as that, which is a y. If I wrote y, that would cause some penalties if you were to do that in an exam. So that will be x2, and that will be 0x3, right? You don't have to write these down because it's question 8, and we're doing the same thing. We're changing it to a linear equation, right? But but the point is these are zeros, and so. Oh, and this is not matrix; it's linear equation, so we don't have to write zeros, right? But nonetheless, so we have this format. So it just means x1, and there's nothing else. So you just have x1, nothing equals 1. x2 again, nothing there, equals 2. x3 equals 3. That's all there is. This is what you really want on the other questions, because all the unknowns are defined already, right? x1 can't be anything, right? It's technically an unknown variable, but we figured out it has to be 1. So these two are essentially the same. That's all there is. So that's that. That's number 8. Number 9. Oh, number 9, 10. Oh yeah, for number 10 and 11. Sorry, number 9 and 11. Number 9 and 10, I see what they're trying to do. It's just, I don't think it's very helpful. Because basically what they do is they give you some linear equations, 3 linear equations with 3 unknowns. So kind of going back to question number 3, right? That's how you define it, right? So 3 equations and 4 rows. And basically they're just saying, well, if I give all the unknown variables like x1, x2, x3, all those things, if I told you what those values are, can you tell me, okay, let me rephrase what I just said. Let's write it down so that people don't get confused. So this is 9. Yeah, it really doesn't matter which one I choose. x3, x2, x3, 1, they're all 1, 3, x1 minus 5, x2 minus 3, x3. Alright, so that's the case, right? So really it's, the reason why I think is a bit, this question not particularly useful, because they give you these set, right? This is what we call set, and I'm just gonna write A, for example, right? That's gonna be 3, 1, 1, right? So again, you can sort of treat this as a matrix in a way, right? So remember the column, there's so that's gonna be unknown 1, unknown 2, unknown 3. We don't put constants in a set like this because it's already 1. We can't define 1 as something else, right? So x2, we can say x2 equals to 1, or x1 equals to 3, 4, or whatever, right? But 1 is 1, right? That's all there is to it, right? So when they say 3, 1, 1, it's implying x1 and x2 and x3. Copy and paste in these unknowns, and then to see if it's still 1. And if you're really paranoid, technically speaking, you should be putting 3 here, 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 1, 1, 1, 1, 1, 1, and make sure that all of them equals to 1. Now, I understand why they do it. I think it may have been a better idea to, but that's 1.2, right? I can't simplifying these equations so that we have a reduced echelon row, which we'll talk about. Yeah, don't worry about that just yet, right? We haven't learned that yet. So for these questions, all I really did was just plug them in and see if they equal to 1. In this case, all 1, right? And if it is, then chances are that's the right one. I think that's the fastest way to solve these questions. So just algebra, as far as I'm concerned. So don't worry too much about it. Just do one or just do one just to make sure that you know what you're supposed to be doing. But yeah, it's not the most useful question that we need to look into. So up to 14, eh? Holy, okay. So oh yeah, 11, very important. This is probably the most important thing we should learn in this section, and this will be carried. 11. So for 11, we basically what we're trying to do is they have linear equations, and then we have to determine whether this has infinite solutions, unique solutions, or is undefined. Okay, so let's look at, well, 11, everything's there. Well, no. 12 is a little different question, so we have to do 11. 11c is going to be x minus 2y equals 0, and x minus 4y is 8. Okay, so yeah, so that's what it is. And if well, we know how to do matrices, I'll just do it quick, just so that you know. Try to keep these spaces as equally as possible to avoid confusion. Maybe the minus sign is a little too big. Doesn't really matter, really. It's just for my aesthetic.